The marks of 450 candidates in an examination are normally distributed with a mean of 40 marks and a standard deviation of 15 marks, full stop. Given that the pass mark is 36 and 5% of the candidates obtained distinction by scoring X marks or more, determine Roman 1 number of candidates who passed exam, Roman 2 the value of X, Okay, so this is the equation from the normal distribution. So we shall first of all scale normal distribution curve like that. So from the equation we can identify that it is as a mean of 40, and then from the equation also standard deviation equals to 15. And from the equation also we've been given that the pass mark for exam is 36, so we can have that 6 is the pass mark. Now remember Roman 1, they want us to find out how many students passed exam. The total number of students were 450. Therefore, we cannot read directly from the table these values that we've been given. So we convert this normal distribution curve into the standard normal distribution curve by using this equation. Z equals to X minus mean over standard deviation. Therefore, Z will be equal to X is now 36 minus 40 over 15, which is the standard deviation. So this equals to 36 minus 40, that is minus 4 all over 15. So from there we divide negative 4, divide by 15. So we have negative 4 divided by 15. This equals to negative 0.227. We can round off. So this is Z. Therefore, we can now draw this normal curve into the standard curve. So it will be like that. So the standard curve has a mean of 0, and then this will be now negative 0.27 like that. So with the standard curve we can read off from the table the area for negative 0.27. We have the table here. We read off 0.27. So from here we have 0.2 is here. So 7 is in this row. Then we identify 0.2, which is this one. Then we find out the value of 7. Yeah, 7 is this one, 0.007. So we have 0.1064. Okay. So the shaded area equals to 0.106. Now, remember the properties of the normal distribution curve one of it is that is symmetrical about the mean. So if they're symmetrical about the mean, it means the area to the right is equal to the area to the left. And another property, the total area under the curve is 1. So it follows that the area from the mean to the right is 0.5. Then the area from the mean to the left is also 0.5. Now, we now need to get the total area to the right of, therefore, the total area to the right of z equals to negative 0.27 equal to, from the mean to this side is 0.5. Then we add the area that we have calculated to be 0.1064. So we have 46064. So this is the total area to the right of z equals to 0.27. Now 0.6064 is the same as 60.64%. That 60.64% of the total student passed exam. But we know that the total students were 450. Therefore, to get the total number of students who passed exam, we get the 60%, 60.64 of 450. So it would be 60.64 over 100 times 450. So we have 6.6064 times 45 times 45. This equals to can multiply here. So we have 6.064 times 45. So this equals to 272.88. So approximate equals to 273 students. So approximately 273 students passed exam. Okay. So we have calculated the number of candidates who passed the exam. Then Roman 2, the value of x, the value of x. Okay, so can also calculate the value of x. We draw, we sketch our normal curve. This is 40. So they say that the student were they got distinction. They got distinction by scoring X marks or more. They got distinction by scoring X marks or more. 5% of the candidate obtained distinction by scoring X marks or more. Okay, so you can, let's have that this one is this be our X, and then these are the students who are scoring. X marks or more, they lie to the right of X. They are saying that this is 0.05. So if this is 0.05, we can easily get this area from the mean up to X, because we know that The normal curve is symmetrical above the mean, and the total area under the curve is 1. Therefore, from the mean to this point, the area is 0.5. Then from mean to this point, the area is 0.5. Therefore, if this area from x to this is 0.05, therefore we can get this area by saying this, that we get 0.500, then minus 0.05, like that. For 1 from a 10 minus 5, we have 5, like that. Then we have, so this is the area between the mean and the value x. But we can easily identify this area from the table. Now we need to identify the area, which is 0.4. The area is 0.45. So from the table, we now need to want to look for this area 0.45, 0.45, 0.45, 0.45. This is 42. This is 450. This is a little bit more than that. This is close, 0.4495. So the area that is close to that. So this is the area. So we identify the set value on the far left, which is 1.6, and then from there we also identify the which is 4, and this side is 4. So it will be plus 0.04, like that. So we have 1.64. So we are saying that this is the set value that will give us this 0.445. Therefore, here we shall now say that set from the equation z is given by x minus mean over the standard deviation. But we have now z, we have the set value. So we shall say 1.64 equals to x minus mean, which is 40, then over the standard deviation, which is 15. So multiply both sides by 15. So we have 15 times 1.64 equals to x minus 40. So 15 times 1.64, 15 times 1.64, we have 15 times 1.64 equals to 24.6. So we have 24.6 equals to x minus 40. So 24.6 plus 40 equals to x. Therefore, x equals to plus 40, x equals to 64.6. X equals to 64.6. Thank you for watching and listening. Bye bye.